Hello everybody, welcome back to VoltWire, Group 1. My name is Angelo Bardos. This is our activity number 5, blinking RGB LEDs. We have about 5 components here, as you can see. So let's head on to the next page. Arduino Uno. This is a microcontroller board powered by the AT Mega 2028 chip, equipped with programmable digital pins that can output PWM signals, allowing smooth control for LED brightness and color mixing. It has a USB interface for uploading code and can be powered via USB or external supply. Its purpose in RGB its purpose for this program it the purpose for this one is to run the program that can be used to send in different PWM signals to reach each color pin of the RGB LED, creating various colors by mixing red, green, and blue in different intensities. A light Now this is the RGB 5mm LED, a light emitting diode that contains red, green, and blue LEDs in a single package, each with its own control pin. By varying the brightness of each color using PWM, a wide range of colors can be produced. It typically has 4 pins, one common pin, either ground or power, and 3 pins for the red, green, and blue pin. This produces different colors as programmed by the Arduino by mixing varying intensities of red, green, and blue light. So now we have a jumper cable. These jumper cables will connect all of the components together in one neat shape. Now so these wi so these wires will carry electrical signals and power between Arduino and RGB LED. Uh, so these wires will carry electrical signals that power between the Arduino board and the RGB LEDs, red, green, and blue terminals, enabling the color correct output. Resistor, electronic component that limit the current flowing to each LED within RGB package. Using separate resistors for red, green, and blue ensures safe operation and consistent bright levels. Purpose in RGB LED prevents each LED color channel from receiving too much current, which cause damage to the RGB LED or cause uneven brightness. Our last component here is the breadboard, a reusable prototyping platform with a grid of holes and internal conductive strips for connecting electronic components without soldering. Provides a neat and organized way to connect the RGB LED resistors and jumper cables to the Arduino, making it easy to modify or troubleshoot the color cycle circuit. That's it for this one. I hope you had a fun time listening, and I'll see you in the next one. Alright, hello everyone. Ah, hello everyone. Welcome back to Arduino testing. We have Act 5 of Arduino Uno. And here we have the same layout as before, but this time what you're going to be using is so-called a PWM pin, which can transmit light to certain pins such as 2 and 11. So what we have here is 3 pins, 9, 10, 11, same as always. And now we have a function down here. So this function is really important to change the colors. So what we have here is int red, int green, and another one which is blue. We have here analog write, which will write whatever the RGB values of these are. So the maximum is 255, from 0 to 255. The red pin is because we want this to be red, and the green pin is we want this to be green, such as the blue pin. Either way, we're now heading on to the loop, which is we have here an integer. You can change this. This is the amount of time that will uh, change the colors. So this is 150 milliseconds. That's about 1/10 of a second. So if you put in any values in these three numbers, you can change the color depending on their RGB value. So this one outputs green, and this one outputs white, this one outputs blue, yellow, and pink. You sort of have to adjust them just so that they look better. Because sometimes when you max them out, they look whiter than usual. So just be careful about that. Alright, that's about it. Thank you for listening, and I hope you all see. I, I'll see you in the next video.
Good day
Peace.
everyone, we are Team VoltWire Group 1 and here we will be making an RGB LED with 5 colors, which is we have the blue, the green, the yellow, the pink, and the white. And so that's all for our colors, and we will be making it now and showing you how it's done. So let's get started. Similar to the fading light and the activity 1 and 2, it's pretty similar. However, the only difference is instead of one resistor, we'll be needing 3 for the accommodating colors such as green, blue, and red. Now first we insert the resistor, also the LED RGB. Make sure that the red traces of the resistor is facing opposite direction of the LED.
Space isa.
Oo. Ayan, nice. Thank you. Okay. Now that's nice. Important to note that you should leave a space for the LED so that we have space to connect the yellow jumper cable into the negative charge of the RGB. The negative charge is the longest rod of the RGB. And once connected to the negative charge, connect it to the GND of the RGB. Now we proceed to connect the rest, such as the red, blue, and green. My tip for here is first connect it next to the resistor without connecting to the Arduino first. Connect it to the breadboard. Now we move on to the pins. Now for our code, the pins of red should be 8, it should be 9,
10,
then for the blue it should be
10,
11.
10,
11 yung blue, green yung 10. Then lastly, for the green, which is the last one, it will be placed in the middle, such as
Hindi. Sure ka yung green yung middle.
May malaysia. Now that all things are set, we shall connect the USB to the laptop. Now we'll first present you with the slow code. This is a slow version of the LED. Now next, we shall present the fast one. Now, for our tip in this is that you should set the average delay for this would be 150, at least 1 second and a half. Because if you set it at least 0, it will just flicker in light blue hue. That is all.
That is all. Thank you for watching and see you in the next video.